Hello, my name is Mr. Roosh, and this is the first in a series of talks where I'm going to attempt to give you a good idea about a branch of mathematics called calculus. I'm not going to spend a lot of time today telling you what calculus can do because that will evolve over the series. But I can tell you this, that calculus is very interesting and it's also very useful. So hopefully that got some interest. I can tell you that it's used in engineering a lot. It's used in all the sciences. It's used in the business world, especially in economics, and it has many other uses. I can say that for sure that we would never have put a man on the moon. You would not have the use of Google search engines or cell phones without calculus, and there's many, many other applications. You have, before this time, learned about algebra and geometry and trigonometry, all really important topics just for themselves, but a real reason you learn those is so that you're able to learn and understand more useful and practical branches of mathematics like calculus. So anyway, usually in a new course, and it's true in almost every calculus book you would see, the first chapter is a review of what you've done before. To me, that is kind of boring. So I'm going to just today, in this first talk, discuss one idea that you have used probably for 2 or 3 years that will be used every day when we talk about calculus, and that's the idea of what a function is. So I'm going to give you a definition that I came up with. It's not revolutionary at all, but it makes it understandable to me, so I'm hoping that it will to you. A function is a rule that assigns to each member of one set of members exactly one value, forming a new set of values. Now that might not be, when you just look at it as a whole, it might be a little bit hard to understand, but if we break it down, it really isn't. So we have all these different functions, and somehow we have to denote what they are. So we usually give them a name. And you could use just about any name, but one of the most common names you have used is f. It makes some sense to have f. Maybe I'll do this in a different color. So it makes some sense to use f because f stands for function. But we could have G, or we could have Sam. You could call the function whatever you wanted to. Now, it assigns to each member of one set of members. So, we have to have something that denotes what we're going to call the members. Again, they could be a wide range of different things, but the most common thing you've probably used is, we'll call those members X. And the set of numbers, it'd be nice to have a name for what the set of numbers, what the set of all those x's are that we're going to put into the function. So we just give it a name. And you've seen this before. It's called the domain. Now, when we give one of these members from the domain to the function, it assigns another number. What do we call that number? Well, if the function is f and we're putting x into the function, that member is going to be called f of x. That's just the way we denote it. But sometimes we want to be a little bit lazy and not write f of x, so we give it a different letter, just a single letter. What's the most common thing you've used? Y. So f of x and y are interchangeable. And now we've formed a new set of these y values. So what are we going to call that? let's give it the name, the range. So, pretty much that's the definition. We have these values of x, we put them into a function, and that forms a new set of values, y values, which we call the range. So, let's just give an example. And there's different ways that we can denote a function. One of them is to make some kind of figure that looks a little bit like an ellipse or a circle if you want, and put in some values. Now, I can put from one value up to as many values as you want. So for this particular example, let's just say 0, -1, 1, -2, and 2. We're going to have 5 x values in our domain. And since we're going to call them x, I'll put a little x up here. And then, magically, we're going to put these x values into this function. So I'm going to call the function f. And when I put these values into f, they're going to form new values for my range. And I'm going to call those values y, or f of x. So, I'm going to make up this particular function. So I have to come up with the rule. And the reason I put the rule in quotation marks is, and some pure mathematicians wouldn't even like me to use the word rule, because technically a function doesn't have to have a rule that makes a lot of sense. But almost all, I would say every function that we talk about this year will have a well-defined rule. So I'm just going to use that term because I think it helps us understand what a function is. So I'm going to make the rule this time where 0, when you put it into the function, becomes 0. Ooh, not too exciting. What does 1 become? Well, what -1? -1 becomes 1, and 1 also becomes 1. Now, some of you might be thinking, uh-oh, every value of the domain has to equal only one value of the range. Well, I think we're okay because every value here only goes to one value here. Now, I couldn't have it. It would not be a function if I had -1 going to 1 and -1 also going to 0. Functions are not ambiguous. You know exactly what every member becomes when you put it into the function. Well, let's say -2 and 2 both become 4. I claim that this is a function. We have a set of values in our domain. We put them into a function, forming a new set in the range. And if we really wanted to describe those to somebody, we could even, in a very mathematical way, we could describe the domain to be all the values of x such that x equals 0, -1, 1, -2, and 2. And the range over here is all the sets of all the y values, and now we've completely described the x's and the y's. Now, there are other ways that we could describe a function. Besides doing this, I could make a little chart. I won't make the whole thing, but 0 becomes 0, -1 becomes 1. I could make a little chart like that. Another way, I could come up with a set of ordered pairs where the first value is the domain value and the second is the range value. So I could describe all the members of my function like that. And if you were sort of an artistic type, which probably some of you are, And like things more pictorially, you could even come up with a little graph where you put all the x's on one coordinate line and the y's on another. So then I could describe one of these ordered pairs when x is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is 1. When x is 2, y becomes 4. And negative 2 becomes negative 4. That would be a more graphical way of showing what a function looks like. In this particular case, although we're not sure, sometimes we can even come up with what the rule is in the function and write it in a very mathematical way. Some of you have probably already kind of figured out that what am I doing to this function, or to these values of x? I'm multiplying them by themselves. Negative 1 times negative 1 is 1. 2 times 2 is 4. So it's possible that what you're trying to describe is the function f of x or y equals x squared. That's what the function is doing. It's taking the value of x and squaring it, multiplying it by itself. Now, if we were going to do it this way, we would for sure have to include this to show what the domain and the range are. For these other ways, the domain and the range are already pretty defined. But if you were doing it this way, you would probably want to say what this is. And my guess is that a lot of you some of you like this way better, some of you like this way better, some of you like this way better. Now, in general, you could do whatever way you wanted to, but when would this way be by far the best way, or maybe this way, that these would not be so practical? What if our domain, instead of being those 5 numbers, what if they were all real numbers? Now, this way would be a blast, but it would take you an awful long time if there's an infinite number of numbers there. Now, with this way, you could just connect all the dots like that. Now, you can't tell exactly what these values are, but at least it would give you a good idea what that function looks like. And from here, you can also easily see that every x value only has one y value. When we go like that, every x value we find only has one y value. It passes what we call the vertical line test to be a function. Now, why is this way so nice? Instead of having to listing everything out, instead of writing this, I could just say the domain is all the values of x, so that x belongs to the real number system. And then the range, because of the way we're squaring numbers, we never get negative numbers. We do get 0. We can say the y values are such that y is greater than or equal to 0. So, lots of different ways of describing functions. These 2 ways are the ways that we use most of the time, because usually we're looking at quite a few values in our domain. Now, if you see this way, you could say, is this a function? And you'd say yes, because it passes the vertical line test. But what if you were to switch things around and call this y and this x? Now you would say, for every x value that we picked there's 2 different y values. So that would no longer be a function of x. However, because of what we've just said, this would be a function of y. Every y value has only one x. Because of that, it's really important to know which values are in the domain and which values are in the range when we're describing whether something really is a function. So in general, we call the values in the domain, these x values, we call them independent variables. And then the values that you get when you put them through the function are called the dependent variables. Why does that make sense? Because they depend, the y values depend on what the x values are and what the function is, where we can independently pick the x values we want. Okay, so this is just one of an infinite number of functions you could come up with. This one happens to take a value and multiply it by itself. If you had the function f of x equals 5x, what would it do? It would take every value in your domain and multiply it by 5. There are some more complicated functions that you've probably talked about in the past. For instance, there's one function that works on ratios of circles. So the values of your domain, the x values, would actually be measures of the degrees or radians, whatever you would want to use, up from some axis. So you plug into the function what this angle is, and what do you get as a result? Well, it's not like multiplying by 5 or multiplying it by yourself. The answer becomes the ratio of this side to the radius of the circle. So when we put in 0 for the angle, you can see if this angle was 0, this side would be 0. So the ratio of this divided by the radius would be 0. If we put in pi over 2 radians, or 90 degrees, that would bring this value of x up to here, and then the ratio, this side would be the same as the radius, so the ratio would be 1. And everywhere in between, you're going to get a number between 0 and 1, because this side keeps getting bigger until it gets to be 1. And if you did want to write this function in this form, you'd see that 0 becomes 0, pi over 2 radians becomes 1, and everywhere in between that, you get something less than 1. And then when you start going over to angles bigger than pi over 2, now, again, the ratio goes from 1 back down to 0. And then when it even gets bigger, now we're talking about this x value as being a negative value, so the ratios become negative. And you get a function y equals f of x that's a little more complicated than this function. And I think a lot of you are sitting there saying, I know what that function is. It's so important that we give it a special name. Y equals the sine of x. And you know that there's 5 other trigonometric functions that you could do in a similar way. And there's even some other functions that you've probably talked about. Y equals 3 to the x. That's an exponential function. There's y equals log base 10 of x. That's a logarithmic function. And they all have special uses. You've heard about exponential growth. when you're talking about many things, the number of people in this world. The sine of x is used in harmonics, in sound. So these all have real reasons. All these different functions are kind of fun just to deal with, but I think the real importance is they show up in the real world. For instance, I'm going to give you one quick example. What if I were to take this crayon and let it go? Well, if we didn't know better, we might think it would just stay there. But because of this invisible force, which you probably have heard of, called gravity, it's going to drop. And if I wanted to know the distance it dropped in the amount of time t it took to drop that far, and later on in the year I'll be able to explain exactly why this function is true, but the two variables are the distance it drops and the time it takes to get to that point. These are two variables. So the independent variable is going to be t, time. And notice I'm using t instead of x, just because it makes more sense in this problem. And I'm going to let the distance it dropped be s. You might think d, which would be okay, but you'll see later on in the year why we use the letter s. So the function now, instead of being y is a function of x, we have the distance is a function of time. And like I said, later on in the year I'll be able to show you exactly why this is true, but on Earth we see that that distance can be determined by 16t squared. So 1 second after I drop it, it will have dropped 16 feet, assuming that there's no floor there to stop it. In 2 seconds, it will have dropped 64 feet. So it's a very practical thing in physics, and calculus will determine this equation, and you see the importance of functions in physics, as they will be in functions are everywhere out there in the world, describing the universe. So anyway, that's why we do functions. I would say that over the course of this year, we are going to talk about 4 things that we do with functions, and that's really calculus. One thing is just doing this, putting a number into a function and finding out what its value is. That's something you've already learned how to do, so we don't even have to review that. In our next lesson, I'm going to teach how to take the limit of a function, which doesn't have a lot of real use by itself, but once you learn how to do that concept of limits, there are 2 other things that really is all of calculus. And that's how to take the derivative of a function and the integral of a function. You just need to learn how to do limits so that you can do these extremely important topics. So that's pretty much how this course is going to go. In my next talk, we will start getting really into calculus and talking about limits. So, thank you.